So, viewers, how is everything? Um, I trust you are actually doing great. I would like to inform you that we are in for serious business. And mind you, one thing about intelligence is that, or success, or a genius, let me put it that way. A genius is 99% perspiration and 1% inspiration. So your consistency in actually watching this video and your inspiration alongside with the questions and the solution, it's what brings about the genius. So I'm looking out to see a genius out there. So please stay tuned to subscribe and keep perspiring by doing what? Following up with our latest videos as we upload. Thank you. Yeah, the last video we shot, it was a very funny video, very funny calculation, but very practical. It's a very practical question. And at this point in time now, we are going to the second question, of which I made it known to you. I'm going to get you updated with the second questions. So now this is the second question, but another question has been added. But let's move around with this question. Now, question number one. It says, a stone is thrown vertically upward with an initial velocity u in meter per second. It reaches a maximum height and returns to the ground. Find an expression for one, the maximum height. Yeah, the maximum height now. Expression, we are not told to calculate, but to find an expression. So how do we go about that? What are the parameters involved? A stone is thrown vertically upward with an initial velocity of v. When a stone goes upward, the initial velocity at maximum height, the final velocity is what? Is 0. Yes, but that maximum height, it has a velocity, the initial velocity at that point is maximum. So u is what? A meter per second is given to us. Then another thing is involved. When we throw something upward, there is a vertical distance, the height. Then we have h. Then the acceleration with which it goes up, which is g meter, we have the g, which is acceleration against gravity, because it's going upward, that is negative in meter per second square. So now we can find an equation. Say it reaches a maximum height to the it reaches a maximum height and returns to the ground. Find an expression for the maximum height when it's going upward. How do we get the maximum height? So what are the equation that can fit into this now? We have the v square is equal to u square plus 2gh. I think that's the best equation. V square is equal to u square plus or minus 2gh. But now that it's going upward, g is negative. The g is negative, so it's going to be while the final velocity it has attained 0 at that point in time. Now we are looking for h now, so we have 0 square is equal to u, then minus 2gh. So we are looking for h now, u square. We are looking for h now. So how do we go about this h now? So the h now is going to be what? Minus u square is equal to minus 2gh. So at the end of the day, we are going to have u square, when minus cancel minus, u square is equal to what? 2gh. So divide both sides by g, we are going to have h is equal to what? U square over 2g. That's the answer. So at maximum height now, of which the velocity on lifting the ground, what was the velocity when the body was on hitting the ground? Sorry, not lifting, hitting. H-I-T-I-N-G. Yes. On hitting the ground. So the velocity on hitting the ground, at that point in time, when the body is going downward, the final velocity is actually maximum. So V, and when the body is coming downward, the initial velocity is coming. The initial velocity is what? Is 0. Then we have the G. The G is positive. Then we have the h. So what could be the velocity at this point in time now? We still use the same formula. V square is equal to u square plus g 2gh. 2gh. This is plus now because it's coming downward. So the u now is 0. So v square is equal to 0 square plus 2gh. Remember, we are looking for what? The final velocity. So at this point in time now, v square is equal to 2gh. So v is equal to square root 2gh. That's the answer. So the maximum velocity, or the velocity on hitting the ground, is maximum, which is what? 2gh. So let's go to the second question. The second question says, A fruit drops from the top of a tree. Question number 2 now. Question number 2. A fruit drops from the top of a tree, 20 meters. The height of that tree is what? Is 20 meters. H is equal to 20 meters. Now, 20 meters tall. The time it takes the fruit to reach the ground is what? They say, what is the time it takes to reach the ground? The time, that is the question is, the time it takes the fruit to reach the ground is dash. We don't know. So we are looking for the t. So we are looking for the time. Knowing fully well that when the fruit drops, acceleration due to gravity is involved, which is what? 10 meters per second square. It's possible because it's coming to the ground. And then at the point whereby it started coming, because it starts its motion at the height, the initial velocity is what? Is 0 meters per second. So now the final velocity, we don't need to include the final velocity now because they didn't talk about it. So what is the time? So what equation actually constitutes this parameter? It's not about equation 3. H is equal to ut plus 1/2 gt squared. Yeah. So we are looking for what? The time. So we have h is equal to what? What's the height? 20 is equal to what? U is what? 0 times t plus 1/2 times 10 times t squared. So we have 20 is equal to what? 1/2 10 times t squared. So 2 here 1, 2 here 5. So we have 20 is equal to 5t squared. So t squared is equal to 20/5, which is equal to what? 4. So t is equal to square root of 4 is equal to what? 2 seconds. So the answer is 2 seconds. T is equal to what? 2 seconds. Now, the second question is the velocity of the fruit just before hitting the ground. The velocity of the fruit just before hitting the ground. The velocity I talked about, the final velocity, actually its maximum at that point in time, just before hitting the ground. Yes, since the height is given to us, and then we've gotten the time now. So let's use this equation. We have the value for v, then we have the time. The time is what? The time we have before reaching the time it takes to reach the ground is what? 2 seconds. Then we have the g is equal to what? 10 meters per second squared. Then the initial velocity is what? Is 0. Is equal to 0. So we have we can use v square. We have the height, okay, because the height is even h is equal to 20 meters. So we can use v square is equal to u square plus 2as. So why using v square is equal to u square plus 2as now? So v square is equal to u square plus 2gh. So u is equal to 0. So we have automatically it will bring us to this formula. Yes. So let's use this one because one will say the u, which is equal to what? Is 0. It will bring us to this formula. So, and this is the velocity of the an object when before hitting the ground. So let's use this formula directly now. So why using this formula directly now? Knowing fully well that the parameters involved are what? The parameters involved are what? G is equal to 10 meters per second squared. The h height is equal to what? Is equal to 20 meters. Then okay, the u is equal to 0. So let's use this formula, guys. So we have v is equal to root 2gh is equal to what? Square root of what? 2 times 10 times 20. Yes. 2 times 10 times 20. 2 times 10 to give us 20. 20 times 20 to give us 400. So v is equal to square root of what? 400 is equal to what? 20 meters per second. So that's the answer. So the answer for this question is what? The velocity just before hitting the ground, which is this, is what? 20 meters per second. Thank you very much. Very simple and easy question. I believe you enjoyed the tutorials. Please endeavor to subscribe, to click, and to share. Thank you. See you in our next video. Stay tuned and keep perspiring. I'm telling you, you've got to be a genius in this subject. See you once again. Love you and have a nice time ahead. Bye.